First question is velocity. So you can just write displacement per unit time. Right. Now you come here, says use the data to calculate K. Whenever this comes, you need to take square on both sides. Now the equation will be V squared equals to Kp and rho. Then make K the subject. So it will be V squared times rho over P. So V is 3.3 times 10 raised to 2. Do check the units if they're consistent. Sometimes they are not. 1.29 divided by 9.9 times 10 raised to power 4. Okay. For some reason it's very dark. No, we don't want that. All right, 3.3 times 10 raised to power 2 times 1.29 divided by 9.9 divided by 10 raised to power 4. So this makes it 0.0043, that is 4.3 times 10 raised to power minus 3. Well, so, but I think I did not square it. I made a mistake here. Wait a second. So what do we do now? Close. It's wrong. Wrong answer actually. 3.3 times 10 raised to power 2 square times 1.29 divided by 949 times 10 raised to power 4. So that is 1.4. All right, now it's fine. Now it says use your answer in data to determine the significant and absolute uncertainty. Okay, we can do that. So we write the equation delta K over K equals to delta V over V plus delta rho over rho plus delta P over P, and there's a square, so you have to multiply with 2. This is 1.4. This is 2 times. Okay, so they have already given percentages, which is great. So we can just write 3%. So 3% is 3 divided by 100 plus P is 2 divided by 100. You don't need to switch percentages, okay? So it'll be 4 divided by 100. And now we can pretty easily do them. 2 times 0.03 plus 0.02 plus 0.04. And then we multiply it with 1.4. So the answer is 1.68, sorry, 0.168. Now, uncertainty is always written in one significant figure. So it will be 0.2, and our answer is 1.4. So it should be same decimal place. That should be the answer. If you have any questions, please let me know. All right. A block X slides along a horizontal frictionless surface towards a block Y. And they've given okay, linear momentum. So momentum is the product of mass and velocity. That's what linear momentum is. Let's say determine the time interval which the blocks are in contact. It would be from this point to this point. So that's about 60 to 100. That's 40 milliseconds. And then it says describe without calculation the magnitude of the acceleration block Y from this to this. So 80 to 100. 80 to 100. So the magnitude of force has to be the same, which means the acceleration has to be same. So it is constant as it is a straight line, slanted one, and from 100 to 120. 100 to 120 is a flat line. So there's no change in momentum. There's no force, which means no acceleration. So this has to be 0. Now, determine the magnitude of force exerted by this. So first of all, we will check the momentum was 0. Here the momentum is 0.50. So the change in momentum is 0.50 minus 0, and the change in time is 40 milliseconds. So we can write that's 10 raised to minus 3. This will give us the force. So because force is rate of change of momentum. By the way, tomorrow I will also upload the full mark sheet. Okay. So, sorry, formula sheet. So you can also look at that. So it has to be 30. Now, the answer was to 12.5. Even if you have written 12.5, that's also fine because it conforms to our rules. Okay, and the rules are minimum significant figure in data or one more. So the answer could be 2 or 3. Now, sketch the variation momentum block X to Y to 160. So block X was moving at this momentum. So we'll start the line. Till this point, we are going to start the line like this. See, and then the thing is that within this time, there's a change happening, but we need to understand what is the momentum afterwards. So for some reason, there must be something given. Block Y. Block Y. So slides this, there's no resistive force, block XY, X momentum is short time later block and then separate. So we need to basically calculate it. So M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. So it had this momentum, block X. This is XY, XY. So this, and it had no momentum. Afterwards, block Y had a momentum of 0.50. We want to find what is the momentum here. So let's put X here. So X will be 4 minus 0.50. That would be minus 0.10. Okay. So what are we going to do? Till 100, we're going to go here. And then we are going to make a straight line. Okay. Use a ruler. Don't be lazy like me. Like this. And then, because they're separated, so it will just be this like this. All right. So this should be your shape of the graph. Anyway, if you still have any questions, please let me know. This is why it's 3 marks. Very good. Very good. All right. Then the variation extension and blah, blah, blah. This is unstretched and this is 2.5 and block is moving downwards. Okay. Block of weight is then attached to a spring. Block is released and begin to move down. At once, instead of block is continuing to move downward, the spring has a length of this. Assume that a resistance and the mass of spring are both negligible. For the change of length from this to this, show that the increase in elastic potential energy is this. Okay. From 0.4 to 0.72. Let me see what is 0.4. First of all, we have to subtract, like 0.4 is 0 extension, right? So it's 0 extension right here. And 0.72 is basically subtract 0.4 from it. That would be 0.32. So that's the extension. 31, 32. So we go to this point. The force is 4. Right. So what we're going to do is half into 0.32, half into 0.32 times, and the force is 4. So 2 times 0.32 is 6.4 joules shown. Now, calculate decrease in gravitational potential energy of the block of weight this. Now, because it has the change is the same, I believe. Okay. So I think we just need to use MGH. MG is 2.5 and the height has to be 0.32, the same extension as the height. So let's do it. 2.5 times 0.32. So that's 0.80 joules. Now, please do not write 0.8 only because it does not have the correct significant figures. It's very important that you look at them. Okay. Now use your information in 1 and 2 to determine the instant when the length is this, the kinetic energy of the block. So first of all, I would like to tell you that gravitational potential energy is going into elastic potential plus kinetic, right? So gravitational potential energy loss was this, elastic potential was 0.64 plus kinetic energy. And now what you do, you subtract them. So your kinetic energy is going to be 0.16 joules. And I think that should be the answer. Then the speed, so that's pretty simple. Kinetic energy is equal to half mv squared. So you might be wondering, why do I write the formula first? And the reason I write formula is because even if my answer is wrong, I still get 1 mark. That's fine. All right. So now we don't have the mass, but we do have the weight, which is 2.5 newtons. So we can find the mass by dividing weight with the gravitational acceleration and then v squared. So now let's do it. 0.16 times 9.81 times 2 divided by 2.5 and then under root the answer. That gives me 1.12 meters per second. You can also write 1.1 if you like. If you have any questions, do let me know. Okay. Then a spherical oil drop has a radius and density to the mass. So the volume of a sphere is 4/3 pi r cubed. You should remember this. It's 4/3 pi, and the radius is 1.2 times 10⁻⁻⁶ cubed. So first we're going to look at this. 4/3 times pi times 1.2 times 10⁻⁻⁶, and then we got to cube this. So
Sir, isn't this electric fields?
It is. Yes, it is electric field, but we can do the first part, don't we? Can't we? We can, right?
Yeah, we can. Yeah.
We will do it. Okay, for some reason the calculator is very bad. So I don't know what it wants from me. So we'll just write it like this. Times 10⁻⁻20 meter cube. And mass is density times volume. So 6,940 times 7.723.8 times 10⁻⁻20. So we must multiply this with 940. So this will be 6.8 times 10⁻⁻15 kg and shown. Rest of it is electric fields, so leave that. That's a very, very long question. 14 marks, oh my God. Okay, never mind. I'm going to question number 5. So it says loudspeaker oscillates with frequency f to produce sound waves of wavelength lambda. The loudspeaker makes n oscillations in time t. Okay, I get it. Now it says what is the distance? So the frequency can be calculated by n oscillations per unit time, and v equals to f lambda. We can't use v. That's not fair at all. So time period would be then equal to 1 upon lambda, right? So time period would be t upon n, I believe. Okay. So we want to find the distance. Okay. Distance. Velocity equals to why? This is strange. There's no velocity. I can't use v. Then how could I find the distance? Let me think about it. Very bad question. So let's suppose this was one wave. So there were n number of waves in time t. So what would be the distance? So if one wave has a lambda, so the total distance would be n times lambda. Divided by t would give me velocity. So this should be distance upon time. So it should be n lambda then. And for time t, because frequency is number of waves per unit time, so t should be n upon f. Yes, would be n upon f like that. All right. Right. Now use your answer to reduce the equation relating speed of sound wave to v is equal to f lambda. Okay. Sorry, we have to use the other formula. V is equal to distance upon time. The distance is n lambda and the time is n upon f. So f will go up, n will cancel out. So it will be f lambda. Shown. Okay. Very stupid question this is. All right, now determine the frequency. We could do that. So the length of this wave scene is 1, 2, 3, 4. 4 centimeters, right? So the time period is equal to time base times the length of one wave. So time base is 0.20 milliseconds per centimeter multiplied by 4.0 centimeter. So I think it should be 0.80 milliseconds. That would be written as 10 raised to power minus 3 seconds. Now frequency is going to be 1 upon time period. So 1000 divided by 0.8, that's 1250. So either you can write 1250 hertz or you can also write 1300 if you like. Okay. Please don't, I mean, just pick one answer, okay? Don't write this in your exam. Either pick like 1300 or 1200. So I'm writing it like this so that you don't write double answers. Please don't write double answers. Now, two sources, S1, S2, right? Explain what is coherent waves. Coherent waves have constant phase difference. That's what makes them coherent. Okay, state the phase difference between two waves arriving position of minimum loudness that is closest to point X. Oh, okay. So 180 degrees because it's destructive interference. Determine distance S1Y. Okay, interesting. So what we can do is that the bar difference is going to be S1Y minus S1X. X S1Y and S2Y. Sorry. Now this is loud sound. This means it has to be constructive interference, right? Now, if you look at it, it's like this, the center of these two waves is exactly here. So there's this has to be n equals to 0, this has to be n equals to 1, then this has to be n equals to 2. So part difference is n lambda. S1y is what we need to find. This is 7.40, right? And this is this n2, so we're going to write 2 lambda equals to S1y minus 7.40. Do we have lambda? Yes, 0.85. 2 times 0.85 equals S1y minus 7.40. So Let's do it. 2 times 0.85 plus 7.40. This would be 9.1 meters. If you have any questions, please let me know. Right. Then question number 6. Explain in terms of energy why V is less than E. So we can always write for the internal energy, and the best way is that energy is dissipated within battery due to internal energy, just like that. All right. Now, state an equation V, I, R, and V. Okay, we could do that. So EMF is equal to potential at terminal or potential loss. So E is this. Potential at terminal is V, and potential loss is I times R. So we did it. Now, so it says the resistance of the variable resistance is varied, and current is also changing. Explain how is it deduced that EMF of battery is 2.8. So we could deduce it when the current is exactly 0, right? So the internal resistance or voltage loss will also be 0, as it is equal to IR if the current is 0. So this means this is 2.8. Okay. So we can say that check the value of V at current equals to 0. All right. Now we need to find the internal resistance. Now, if you look at it, it's a tricky one. So EMF is equal to V minus plus IR, right? So this is our equation. Now, what do we do? Let's make V the subject. It will be E minus IR. So I can rearrange it as minus IR. So let's write RI plus E. Can I write it please like this? It doesn't really matter, right? Now the reason that I'm writing like this, because I want to compare this with y equals to mx plus c. How can I compare this? Because it is a straight line with the intercept c. So from this comparison, I can say, I'm changing the color to show you that v is on the y-axis, as you can see. X is on like I is on x-axis, right? This means that the intercept is EMF, which we found out to be 2.8, and the gradient is minus R. Do you guys understand? So this means I got to find the gradient of this curve or line. So my first point is 0 and 2.8, and I can pick this point then. This is 1.5 and 0.567. Then what I'm going to do, I'm going to find the gradient. So the gradient is going to be y2 minus y1 divided by x2 minus x1, just like that. And then I'm going to get 0.7 minus 2.8 divided by 1.5. So answer is minus 1.4. So this is my gradient. And I know from this that if it is minus 1.4, it is equal to minus R. So R has to be 1.4 ohms. You guys understand this? All right. Good. Now the battery stores 9.2 kilojoules of energy. The variable resistor adjusted so that the voltage is 2.1. Use figure to calculate the resistance of R. Okay. So first of all, what I'm going to do, I'm going to check at 2.1 volts, which is right here. Then what is the current? So the current here is 0.5, right? So I'm going to write current is 0.5. EMF equals to I times R, that's the terminal potential, times IR. So EMF is 2.8, current is 0.5, R plus 0.5, and the value of resistance of that is 1.4. So let's solve this now. So 2.8 minus 0.5 times 1.4 is 2.1, and you divide by 0.5. So R has to be 4.2 ohms. Don't need to write that. Then says calculate the number of conduction electrons moving through the battery in time of 1 second. Interesting. Okay, I think we can do this. Charge passing would be current into time. The current is 0.5, time is 1 second, so that is 0.5 coulombs. If one electron has a charge of 1.6 times 10 raised to minus 19 coulombs, then how many electrons will be in 0.5 coulombs? So we're going to cross multiply now. So n is going to be 0.5 divided by 1.6 times 10 raised to 19. Oopsie. So this is 3.1 times 10 raised to power 18. If you have any questions, please let me know.
Sir, for D1, we can just use V is equal to IR as well, right?
V equals to IR. Well, yeah, we could do that. Why didn't I think like that? That's correct.
Okay, I was just confirming.
Yes. Very good, very good. Okay, determine the time taken for energy in the battery to become equal to this. Assume that the EMF of battery and the current remains constant. Wow. What is this question? I think we can do that. Energy is given by V, I, and T. So the voltage at that time, determine the EMF and the battery. Okay, the voltage we need to find. That's interesting. No, we want to find the time taken. So the energy goes from, what was the energy before? 9.2 kilojoules. So 9.2 times 10 raised to power 3 minus, so this is the change in energy. The change in voltage, or do we need to find the change in voltage really? So EMF is constant, so we can just use 2.8. The current is 0.5 because it's talking about within the battery, right? So we can't use the other EMF voltage times T. Okay, now let's do this. 9.6. Oh, chalo. Give you enough. 9.6 times 10 power 3 minus 1.6 times 10 power. Okay, this should be 3, not minus 3. 3. Okay. 8,000 divided by 2.8 and divided by 0.5. So the time is 5714 4.28. That would be 5.7 times 10 power 3 seconds. All right. If you have any questions, please let me know.
I got 5.4.
You got 5.4?
Yeah.
How? Why? Didn't I write the correct thing? Oh my God. See, my mistake. I took 9.6 for some reason. Sorry. Then your answer should be correct. It should be 5.4. Because I took 9.6 in my calculator. Let me confirm it, okay? 9.2 minus 1.6 times 10 raised to power 3 divided by 2.8 divided by 0.5. Yes, you're right. It's 5.28, 5.428. That's correct. Okay, now question 7. One of the results of alpha particle scattering experiment is very small minority of alpha particles scattered through the angles greater than this. State what may be inferred from the structure. Okay, so this is the third condition that we wrote, okay, in the notes. So you should be remembering that all the positive charge is in the center, and all the mass is concentrated in a tiny nucleus. Well, not all the mass, but we can say almost all the mass. Okay, now then says a hadron is overall charge E. So this baryon. One of the quark is a strange one. So in terms of E, charge, okay, 1 by 3 E minus. The other two quarks in the hadron have the same charge as each other. Okay. By considering the charge, determine the possible type, flavor, other two quarks, explain your working. So what do we need? We need that's not fair. The other two quarks and neutrons have the same charge as each other. Okay. Okay. Well, that could be done. So it could be up, S maybe. You can use other ones as well. So it's 2 by 3e plus 2 by 3e minus 1 by 3e. That should give us 3 by 3e, which is plus e. It should be up, and strange. Is it clear? All right. I think that would be the end of the.
Sorry, what did you do over there? I lost track.
Sorry, should I do it again? Like,
yeah, the last one.
Okay, so what I did, it says there are two other quarks that have the same charge as each other. And the overall charge of this hadron has to be plus C, right? So I want to do 2 by 3e plus 2 by 3e. And then you have one strange that is already there. If you add them together, it is going to be 3 by 3e, which is just plus 1e, right? Now, this is either up, top, or charm. Up, top, or charm. So you can pick any. So I picked up, and strange. Do you understand? That would create plus 1e. Okay.
Yeah. Thank you.
All right. So that's the end. If you guys have any other questions, please let me know.